Chapter 2, Section 2 is all about conditional statements. By the end of this lesson, you should be able to identify, write, and analyze the truth value of conditional statements, and you should be able to write the inverse, contrapositive, and converse of a conditional statement. So let's define conditional statement. A conditional statement is a statement that can be written in the form if P, then Q. There's two parts to every conditional statement. You have a hypothesis part and a conclusion. The hypothesis part of a conditional statement always follows the word if. The conclusion, for the most part, follows the word then. So in this example, if an angle has a measure of 90 degrees, then that angle is a right angle. So this part right here is my hypothesis. If an angle has a measure of 90 degrees, then I can draw this conclusion, that that angle has to be a right angle. We use this symbol, P, then Q, a lot. A Venn diagram just states that if it's in P, then it also has to be in Q. We use that a little less, but we'll use the symbols again today. So you will have to identify a hypothesis and a conclusion, and it's not always going to be as easy as this one. Hopefully this was pretty easy. You had the if part and then the then part. Sometimes they like to switch things around to make sure you're paying attention. So a number is a rational number if it is an integer. Your hypothesis will always have an if on it. So in this case, this right here is your hypothesis. If a number is an integer, then that number is a rational number. This is going to be our conclusion. So sometimes they switch it around, but know that your hypothesis will always have an if. And then other times you're going to have to write your conditional statement. And we always like to write our conditional statements with an if-then, just to make it easier on the reader. So write a conditional statement from an obtuse triangle has exactly one obtuse angle. So start with if. If a triangle is obtuse, then it has exactly one obtuse angle. So you take the information that they're giving you and you turn it into a hypothesis. If it rains today, if this happens, if your triangle is obtuse, then it has to have exactly one obtuse angle. And we're going to do a bunch of examples with these in class so you can get some more practice. But every conditional statement has something called a truth value. That's stating if something is true or false. And it's false only when the hypothesis is true and your conclusion is false. So your hypothesis has to be something true. It has to be a true statement. So determine if each conditional is true. If it's false, give a counterexample. And remember from yesterday, we only need one example that doesn't work to prove something false. So if this month is August, this right here is my hypothesis. And this has to be true. So in this case, we're just going to assume that this month, whatever they're talking about, is August. Then, next month is September. Here's my conclusion. And is that always going to be true? If the month we're in is August, the next one has to be September. We go June, July, August, September, October. It always goes that way. So this is true, or it has a truth value of true. And then the next one, if two angles are acute, then they are congruent. So again, we assume that the first part, our hypothesis, is true. So we're going to assume that two angles are acute. Then they are congruent. Here's my conclusion. So, congruent, remember, means same measure. There's plenty of angles out there that could be acute, and they're not all the same. So this is false. And then we have to come up with a counterexample. So something like 30 degrees, that's acute, and 45 degrees, also acute, but they are not congruent. So remember, all you need is one counterexample, and you could have come up with anything for that. In addition to having a conditional statement, you have something called related conditional statements. And we're going to use these throughout our proving. You need to know the definition of converse, inverse, and contrapositive. So remember, our conditional statement is always if P happens, then Q happens. The converse switches the hypothesis and conclusion around and says if Q, then P. The inverse negates the hypothesis and the conclusion. So it would be like, if not P, then not Q. So two negatives. The contrapositive switches them around again. So we have Q first and then P. And then we also have the nots. So if not Q, then not P. So you're going to be given a statement, and you're going to have to write the converse, the inverse, and the contrapositive. So here's my conditional statement. If an angle has a measure of 90 degrees, then that angle is a right angle. So the first thing you should do is identify your hypothesis and your conclusion. Because this is our P, then Q. So remember, your converse is going to take Q, then P. So when we go to write this, all we got to do is switch these around. If an angle is a right angle, then it has a measure of 90 degrees. And make sure you stay away from saying it or that. If an angle is a right angle, then that angle has a measure of 90 degrees. So don't say then it has an angle of, or then it has a measure of 90 degrees when you're writing it out. So that's our converse. We just switched around our hypothesis and our conclusion. Remember, inverse goes back to the way it was given to us. So hypothesis comes first and then conclusion. But we say not P, then not Q. So this means we just throw a not in there. If an angle does not have a measure of 90 degrees, then that angle is not a right angle. And then finally, contrapositive. This is kind of a combination of the last two. We're going to switch around the Q and P. So switch around our hypothesis and our conclusion. And then we also negate them. So if an angle is not a right angle, then that angle does not have a measure of 90 degrees. And then in addition, you might have to identify the truth value for each of these, which just means, are these statements true or false? So we know the first one's true. If an angle has a measure of 90 degrees, then that angle is a right angle. That works every single time. How about if we switch it around? If an angle is a right angle, then that angle has a measure of 90 degrees. Well, that's also true. So let's read the inverse. If an angle does not have a measure of 90 degrees, then that angle is not a right angle. So any angle, not 90 degrees, like let's say 85, that angle cannot be a right angle. So this one's also true. Contrapositive, if an angle is not a right angle, then that angle does not have a measure of 90 degrees. So no right angle, no 90 degrees. That one's also true. Sometimes not all of them are true. It depends on how things are worded. So once you make the converse, the inverse, and contrapositive, you're always going to be asked its truth value. Double check that what you did makes sense. So it's the end of this lesson. You should be able to identify, write, and analyze the truth value of conditional statements. And you should also be able to write the inverse, contrapositive, and converse of a conditional statement. And we will do lots of practice with these tomorrow. Have a good night.